Hey everyone, thanks for all coming and thanks to Cam for organizing this awesome event. It's the first time it's running this year, so I'm really happy to be part of it. So yeah, a bit about my background. I'm a software engineer, so let me know if you can't hear me, by the way. I tend to mumble, so I'll try to speak clearly. As a software engineer, I guess my focus is always about building products and features, and so testing is sort of a second thought to a lot of people, but it's a huge part of obviously delivering a project. Whether you're a consulting or a product team in a big company like Facebook, it's always a huge part of that endeavor. So I think at the same time as developing, you always want to make sure that you're keeping the verifiability and like the testing in the back of your head. So as this talk sort of arose, I came from I guess my own software engineering perspective, but I wanted to make sure that it was consumable to everyone here, majority of which are sort of like senior testing engineers. So I'll go through, I guess, a very quick introduction into testing. It's more like a refresher for myself more than anyone else really in this room, considering I don't work in this field. But I still appreciate all the challenges that it faces and also the opportunities. So moving forward, why should we even write tests? So writing out this slide, I guess I was trying to find all the benefits that you would want in a testing suite to give to the product. So when the business asks you, like, why did you spend this much money on this many engineers and like all this time, what are we actually trying to get out of it? The first step would be, verifying functionality. So as the software is being built, you want to make sure that it works, and not just on your own machine. I think this happened a few times with me and Cam, where he's told me like, this thing isn't working, and I'm like, but it works here. Like, and often the time, yes, it's like an environment problem. So that might involve fixing the environment, or like maybe my own code half the time. So it can be half-half. Building resilience for, I guess, the regressions is also a very important factor. So as we were building very large systems, you'll find that a lot of the code you built in the previous weeks will start to fail in different various strange ways. So it's not always foreseeable, but it's always important to have a pretty resilient test bed that you can always run and repeatedly run to catch those regressions you don't expect in previous parts of the application. It also builds confidence in the system. So if you want to, say, demonstrate this product to the greater team or to business, you don't want to have it fail in a demo. I think along with sort of the test framework that we built at Tabcorp and various other places I've worked, it's always been a crucial part of making sure that we can deliver a product and also demonstrate it at any given time and also know that it's going to succeed. And also, it helps document the progress of the team. So as you go through the many weeks of building different parts of the system, it's always good to have like sort of a executable documentation almost of the entire platform or application you're building. It helps to sort of like acknowledge people's work and also verify that it's all working correctly. And it's also kind of like a good storyboard to sort of show the workflow and play it back in demonstrations even. And Cam did a lot of this like in his demonstrations every Friday at Tab, like just running through the test suite and making sure that everyone can see visually that this is actually executing, it's verifying all the features that we've built and that we're good to deliver. And aside from that, it can often find like edge cases you didn't consider during the planning phase. There's a lot of like planning that gets completed before you even start writing any code, but often there are sort of edge cases that you haven't considered, and this can come out when you're sort of testing with the I guess the framework and like writing these tests on the actual code. Like Wi-Fi. My Wi-Fi is kicked out. One sec. Yep. And then the other question that comes after that is, why don't we write good tests? So why don't we write tests at all? And there's a bunch of reasons why. Majority of it is just cost. Like the cost to write the tests might be high. So in terms of time and labor, you need people, engineers and software engineers to maybe write unit tests as they're building code, and that has to be maintained. You also need QA engineers and automation engineers to make sure that they build the overall framework and they continue to maintain that framework. Requirements will change throughout any project, and it depends how complex the project is and how much change you'll see, but there's no project that doesn't change throughout some point in the timeline. So making sure that you build a system that's resilient is challenging, and that's why it's a multi-person effort, and you have entire teams dedicated to it. And that can often be too costly for some teams and some projects. So it's one reason why maybe you don't want to take that burden, which is unfortunate. And so I think a lot of these reasons might be that people within their own team decide not to do it. I've been guilty of the last for many times. Like if I'm building a very small piece of software, I'll be like, I'm just prototyping this. I don't really need to like write a sort of a comprehensive suite across the entire functionality of this tool. But for very large systems and like all the huge companies that you're coming from, I think that it's a huge sort of cost, but it's one that we definitely need to invest in if we're going to see the verifiable sort of results and the success that we want from our products. And this is really simple and stupid almost to have in this kind of talk to your audience, but I think at least for me, it's important to keep in mind when I'm like going through these frameworks that the main sort of benefits that the framework is aimed at is going to be at different levels of the testing pyramid. So if we want end-to-end testing, the majority of that will be in the top of the pyramid for UI tests and acceptability tests. I think writing more unit tests is obviously a big plus, and you'd want that to sort of make up the base of that pyramid. So as you're deciding on the framework, you need to know what kind of problems and what kind of tests you're basically tailoring it for. If we're testing functionality, it makes sense to obviously have end-to-end tests, and then unit tests will make up the basis, as I mentioned. So you also may want some in the middle that kind of interrogate the UI, but they don't actually run in the browser per se. You may want to just render some components to a headless browser, or maybe even in process, and then just verify that the outputs are what you expect. So today I'm going to try comparing a bunch of end-to-end frameworks, and there'll be a bunch of pros and cons. And as an engineer, this is exciting for me because if I was starting a new project, whether it's at work or outside, and I use React a lot in the past and today, so I want to make sure that I know what's out there for testing, and so that I don't leave it as like a last stage in the project, but I actually start it off alongside everything else I do, like the build pipeline and Webpack and all that other stuff, and setting up Babel. I want to make sure that the testing framework is up there with the others in terms of like the pillars for the foundation of the app. And that's the same thing for like if you're on a team joining a new project or building a new product. You want to make sure that you take that into consideration. And so React is a big framework that everyone uses today, and like it's sort of superseded like with Angular, and so a lot of that is sort of changing. So I was keen to see like what's out there today that wasn't out there like say like 2 or 3 years ago when I was playing around in Angular that we can use for React. So that's what this talk is kind of geared towards. Another important factor of this is sort of TDD. So as you go through the cycles of test-driven development, this sort of highlights like the general flow of how you write tests. It's very simple and like easy to understand and intuitive, and I think everyone's done this without thinking about like sort of drawing on like a page. But essentially you start off with the red zone or the red state where you either have no tests or the tests are failing, and you may have very simple code that at the moment doesn't build properly or doesn't run. And so it's the initial stage, and then if you see that a test is failing, you'll basically move to the green state by trying to find the very smallest, simplest additional steps you can put into the test spec or into the code to get it passing. And so you might implement like a naive solution to like an algorithm if it's like finding things on the page or something, and then you'll write very small steps to the test spec just to get it working and going green. And then you don't want to leave it in that state because it doesn't really fill all of the stages of your test spec, and it doesn't really tick off all the functionality that you wanted to test. So assuming then you complete the code and you move on to the stage where you're adding in all the steps you need into your spec, you go through this sort of refactor phase where you're improving both the code and the spec. And it can happen like in tandem, or it can be that the code is written first. Ideally, you should have some specs, so following the TDD approach, you would write something very small just to get it going, and then as you find like maybe the developers go back and start adding more features, or maybe that kind of stuff happens organically, you want to also make sure that the test suite is following that sort of progress. And then you may also find that you go back into the red zone if you find more errors appearing, and then you sort of resolve those, and there's a cycle that sort of continues like this. So then what are the qualities of a good test suite? I wrote these out like from a few articles I read, and it seems like these were the common patterns I found. You want it to be comprehensive, so you want it to make sure that you capture all the functionality that you're trying to test for. All the boundary cases, all the edge cases that you could consider should be handled by the test suite. That way you're guaranteed that you've at least covered all the basic cases that you talked about when you built the product. You want it to be reliable, so this is a big plus obviously. If you want to run the test suite, you want to make sure that it runs repeatably, and it doesn't fail every sort of fifth time or something. And this becomes a big thing in like continuous integration systems. Obviously, you want to make sure that you run this at a routine sort of schedule, and maybe before every time, sometimes someone like merges code in, just to make sure that it's doing its job. It should be deterministic as well. So one of the challenges that I faced a lot in the past was that it would run fine in CI, but you would get different results every time you ran it. And that's a bad sign. And this is a big problem, I think, with a lot of frameworks that tend to be based on browser technology that's very sort of event-driven, and you have a lot of timing issues that might arise from that. So it's a big problem to have, I think, and it's a challenging problem to solve. But if you have a test suite that's deterministic, then it's a huge plus. Thankfully, unit testing, sort of a back-end system, is kind of the opposite end of the spectrum, where you tend to have the same results every time you run it, and you can guarantee that I guess it's testing the code correctly. And if you have that on the front end as well, it's a huge plus. And like the disparity between the two is quite a big contrast, I've noticed in the past. And so if you can have a front end system that has that sort of resilience as well, it's a huge benefit. And it should be efficient. So if it takes like hours to run, it's not surprising that people aren't going to want to contribute to that giant pile of test cases. You want to make sure that it runs as quickly as possible. And this is kind of a battle that you need to fight throughout the entire project, I've noticed. So often you'll start with something that runs very well initially, and you just keep adding more and more test cases. And it's a linear problem, and so it'll get slower and slower. And oftentimes it can become even more complicated, and you'll have various parts, and you might add like an auth layer, and then say you need to like have a login step, and all these add up over time. And then as you reach the end of the project, you might realize that you've kind of crossed the threshold of usefulness, to the point where it's like we still need the test suite to run, but now we're making sort of drawbacks in terms of when to run it, because it's just so massive. And so having a framework that's built in I guess with speed in mind and like simplicity means that people will happily contribute to it, and it's joyful to use, and also that it runs very efficiently in CI. You want to make sure the tests are isolated. So what that means is basically you can run them individually, you can run them in any order you want. You can parallelize those tests, and the framework, if it supports that, will mean that you can actually like drive more performance by scaling up to multiple instances in continuous integration rather than having it on one machine. Ideally, it should run on multiple machines rather than just like one person's laptop. That's often what happens like when you start off, and then eventually, once you start building a more, comprehensive framework, you want to make sure that it runs in multiple different environments, and like you can scale it up. And that's one way of tackling, I guess, the efficiency issue, is if you just throw more compute power at it and you're able to parallelize, it gets away with like having a complex sort of set of steps that might be very slow to run on one machine, but if you use parallelism, you hope that you can have like multiple nodes on the same machine. And you also want low duplication of code and like of specs. So ideally, you want to build like a reusable and maintainable piece of code in the framework, so that you could then apply that to different projects, whether it's different projects in the same sort of organization, or whether it's like an open source framework you're building and applying to different sets of projects that you work on. You want to make sure that you have a lot of reuse out of what you're building. So yeah, you basically kind of want someone like the Terminator as your test suite rather than Jar Jar Binks. You want someone who's like comprehensive and reliable, and it's kind of like a robotic system, but it's very powerful and capable, rather than things that are just always different every day and like things are breaking left and right. The other problem also during, I guess, the development of a test framework is to how to identify the element. If you want to find things on the page, which is a huge thing in end-to-end testing, there are different ways you can go about this. So one way is to use the XPath, and that's sort of an XML language schema sort of definition, and that basically lets you target a nested element in the structure, however many levels deep you want it. And you can also use functions for like finding elements that contain a certain piece of text, and you can go down and drill down as deeply as you want. It's very specific, so it'll find the element very accurately every time. But the problem is that it's very complex. It has a lot of, I guess, language in that schema definition. And it's also relying on like a nested structure, and that structure could change if, say, you have a pesky software engineer like me going in and adding like a wrapper div around it just to make it look pretty and pop or whatever, and it ends up breaking the test suite for a completely different reason than what you expect. So seeing red like in areas where you don't really anticipate is a bad sign that the test suite is not very resilient. You want to make sure that you're looking at the places where the test suite is failing because the code itself or the functionality is broken. So that takes away from time that you can spend somewhere else. So you want something that's more resilient than this. The other example might be like CSS classes, and that's pretty easy to implement. You just add an extra class for the component into the set of classes that you have. And some of those are used for styling. So it's easy, but it means that it might also conflict with a lot of other things that people are using for just the general layout of the page. And this happened quite a few times, I think, on our project where we were using that kind of system, and then it ended up breaking because people were like adding and removing classes, and some of those classes are like added in code rather than in the template, so it's kind of hard to track where they get included. And so we went with the third option. Most of the time, I think we found that that was the best medium between the two, and that's data attributes. So if you just have like an attribute, say like data test ID, you can kind of sprinkle this across the different components that you want to include in your end-to-end framework. And then that way it's more resilient than classes, and it's quite specific. So the intent is very clear that this is a test ID. You should not be changing this for changing the layout of the page, and you shouldn't suddenly remove it. So if you're sort of migrating between components and like moving things around, I was always trying to make sure like I don't remove or destroy any of that that's there, because I know that it's going to pick up in the test suite. The only con that I could think of really was that it might involve a bit more steps to like configure in test frameworks if they are sort of more geared towards like selectors and like finding classes. But it's kind of a very small point, and most test frameworks are very powerful. They have like selectors you can use to find these attributes. So going into the React world, which is the web framework that we're using today, you basically have a nested structure of components. We can consider that to be a tree. So what does that mean? On the right side, basically you might start off with like a to-do list, and then within that you'll probably have like the actual list component, and then say a card that has like details about the individual item, and then you might have like a checklist item for that particular to-do. And so these are all nested components, and the beauty of that is that you have I guess a structure that's recursive. And so you can expect that a component will have children that are also components. There won't be anything else thrown in there that you don't expect. And that way you can kind of build this framework that renders in a deterministic way. So what does that mean? Basically, React is built as a functional or stateless framework. So you essentially get given a set of inputs, which are the properties. The state can also make a part of that. And then you have transformations. So you might consider these sort of like helper functions or things that transform the inputs into outputs. So in the case of, say, the to-do app, it's going to be basically the individual items, and then the state if they're complete or not, that kind of thing. And then the rendered output will be like the set of sort of cards and checkboxes and things. And what should happen basically is that if you're given the same inputs and you have the same transformation functions, the outputs should be deterministic. You should never get different output from the same input. And that's why it's sort of idempotent. And that's a really useful, I guess, trait to have, because it means that you can cache things. Debugging becomes much easier. You just know what to expect. So you might have dumb components, and they're sort of simple, very small, like buttons, for instance, or input boxes, and they don't have a huge amount of like state to begin with, and they certainly don't make API calls or anything like that. It's just a very easy to test small component to a much larger piece. And the fact that it's composable means you can use it across different pages and sort of have like a design system almost of these are the different UI elements that I can have, and they're very consistent across the entire application. And then you might have smart components, and those are kind of like I guess components that can have state that's global to the application, make API calls, and so you tend to have fewer of those at the very top, and then you kind of nest down to the demo components on the bottom. So the demo app I created for this talk was basically, I didn't do a to-do app like a Hello World example. I actually went with a contact list app, so it's a bit different, but basically it's just purely React, nothing crazy going on. I'm not even using any state management aside from like the internal state, just to get it as an example. And then you can also check it out here on the link and go through the examples I'm going to go through today. But the whole exercise is going to be presented today is going to be just showing the app off, and then also testing different frameworks and contrasting and comparing the benefits and the negatives. So I can like launch into the example now and just show you the application running. It's a very simple application. Oop. Went to the port I usually use. So basically it's a contact list, and you can scroll through the different items. You can add, remove different contacts. You can search for them. I'm using the same form for like editing and creating. So this is just meant to capture like a general purpose application that has like sort of create, remove, update and sort of delete, read and update, delete, sort of as operations you can do on simple models. And in this case, it's just a contact model. So what we're going to do now is go through some frameworks, and I'm just going to contrast the different benefits. And what I found as a developer to be really easy to use, coming from a background where I'm not used to jumping into sort of building a test framework, I think it'll be quite rewarding to see like which ones stick out as like obvious cases where I would go for if I was starting a new project. So the first one I looked at was WebDriverIO. And it's probably the most popular one people think of. WebDriver itself from Selenium has been used for like the last 10, 15 years, and it's very obviously widely adopted. We definitely use it at Tab with Protractor in Angular. So I wanted to see what would be sort of a React solution to this, and whether it would have the same, I guess, challenges we faced, and whether things have improved since then. So it's pretty modern take, I guess, on like WebDriver. The fact that it's written in Node.js means it's somewhat isomorphic, and like you can use different utility libraries in like the entire sort of JavaScript ecosystem. And it has the option of like having asynchronous, asynchronous modes, so you can run code that sort of blocks on each line and like completes the step, then goes to the next step. But you can also sort of make your code asynchronous, and then that way you can run them in parallel and have multiple nodes hitting at once. It can use whatever assertion library you like, so it doesn't really force you down one path. It also doesn't force you down any browser path either, so one benefit is that you can use whatever browser you want, typically that supports some driver. I've used Chrome today, but you can use Firefox like we did at Tab. And you can use whatever assertion library you like, assuming that it's a JavaScript-based one, so as long as we're in the Node environment, you can use whatever you like. It also is framework agnostic, so you can use Mocha, Jasmine, or Cucumber or anything else. You can use the Gherkin syntax if you feel like, that kind of thing. So it goes well with like coffee, tea, and pickles, basically. So anything's covered. I think this is getting to the Terminator thing as well. They're going for the robot, I guess. But let's jump into the code now. Just to show you the structure of the project, I'm going to zoom in so people can see. Black and white looks good. So, white and black. It's basically very simple. It's basically 3 components. We have the application sitting in the index, and it's just rendering a bunch of paths in like a router. The very first one of those is the list. Then I have the create form and the edit form, and they just reuse the same form. Within the render list itself, you see the list component. It's got a bunch of items. I'm just loading in from the JSON file that I have in the assets. So it's just a bunch of like fake names essentially. And then it's rendering the items. Then I'll have buttons in the items. So if I go to the contact list, you'll see that it's just a set of contact items, and then they have buttons for editing and deleting and so forth. So if we want to try out WebDriverIO, assuming I have my my app running in a different tab, I can go to, let's take a look at the package.json first. What I did was I added the packages that were needed for running it in the command line, and then also I used Mocha out of the box because it comes as the standard, and there's a bunch of simple reporters and runners, and so it kind of sets everything up for you. You then have the Chrome driver, but you can always add your own if you want, and use Firefox if you want to try different adapters. And all it does is basically runs the configuration I've provided. One thing to note was that there were a lot of configuration steps that are available to you. If you've used WebDriver before, then you know that this is out there, so you know what to expect. You can try different browsers and have different, I guess, routes to hit, and then you can have different configurations for adjusting, I guess, in CI and different environments if you want to. I think, changed 1 or 2 just to point out like where the specs live, and then also what URL to hit when I start the tests. So the tests live in a directory I created called WDIO. Within that, I wrote a very simple spec that all it does is just loads the page and then just verifies that I can find at least one item. And so I just run that with the command line interface that it provides. Okay. So what that'll do is it'll fire up the server and then load the client, attach it to Chrome, and then it just loads the page and like verifies that it works. One thing to note that I realized while doing this was that at least in this current configuration, there's an issue that I've noticed where the delete session doesn't work. So it seems like the server is dying before it actually has a chance to gracefully shut down, and then the client freaks out that the server is no longer responding. So that's something maybe that I guess Arun can help me out with later, but it's one thing I just didn't know how to sort of fix in the last minute. One thing to consider, I guess, is that WebDriver has a lot of sort of bells and whistles and a lot of configurability, but out of the box, it was a bit more of a process to start up and like get going. So if I want to create a new spec, maybe for creating a new contact, I can do that here. Just to show what that looks like, you basically hit add, type in a bunch of stuff. If you miss anything, it'll tell you, and then you hit save. And you're back to this page, and then you can find where your item is on the bottom, for instance. And because it's stateless and like I haven't actually persisted anything, I can just refresh, and it's a good quality to have. But I think as you're writing test suites, that's not the case. You'll have persistent storage, and like you'll basically have to make sure that tests are actually isolated, and that's a challenge. But for me, it's just a very simple sort of object model. So if I want to write a new spec, I would go about writing a new test. So it would be, it should create. And so the first thing we want to do is basically hit the browser and load the right page. And we want to probably click on the button, the add button. So I need to find that on the page now. And if you want to check out the, one thing you might have noticed here is that I can actually use this React plus $sign method, and that'll find a component on the page that I can then target. So we could do that. There's a whole bunch of other ways of like selecting items and text and all kinds of stuff. So assuming that we know that we have a button on the page, and I always like using the inspector in Chrome DevTools to find various elements on the page. It lets you sort of play around with the styling, but also just to identify what you're looking for. So I can probably target like the class contact list add as the button. I haven't used attributes like test attributes as I mentioned before. Just as a simple example, I've just used classes and that works fine. Just shorter to read. So I might want to look at the button and say, let's say you use that class. And then I probably want to click on it. So I think the interface is like this. And in order to like sort of pause and make sure that we're on the right page, I'll say pause it for a while just so we can verify. And I can also focus on tests. So this is all just regular Mocha. I can focus on that test just to make sure that it only runs that one, so it's faster to verify that what I've done is correct. If you give that a go, it should hopefully click on the button and go to the next page. Cool. So now I want to verify that I'm actually on the right page because it may not have worked. I might start to try interacting with the form, and then it'll probably complain that the inputs don't exist, etc. So the first pass is probably just verify that this is the title that appears at the top. You probably want to tell the user that you're on that page. So what I would do is look up for the element. I'm guessing I can look at the h1 element, and then I can use this syntax that it provides. I think I actually need to store the text in a variable in this. So I'll probably like the h1 text or something. And then once I've found the h1 element, I can just say get text. And then I also want to verify that text. So it uses chai out of the box. So I can just use the regular expect syntax. I've just included it up here. See how that goes. Text not defined. Does that count as a bug? I don't know. I'll allow it. Cool. So it's found create contact, and it's just paused there for me. The next thing I want to do is basically fill out the form. So if you look through the API, you'll find that it has a bunch of options for inputs in the API. I believe there's a type. Add value, sorry. So you can add values into form inputs. And we'll probably use that to just fill out the form. So if we look at the form itself, that's why I like to jump just back into the inspector, because the React template may look a bit different to what you expect on the page, and it's probably nested and stuff, so you have to go through source files. But this way I can just find, oh, it's an input and it has the name. Cool. So I can basically type in, find me the element that has as an input, and then the name is basically name. And then I want to add the value. Let's say foo. I'll just foo everything. And then I'll find the next input, and that's just the phone number. And then I think it's called street. And then the city. So after I fill all that out, I want to hit the save button. And that will just be, I think, a button of type submit is a good way to do it. So I think I can write a query like this, where it's just a button and the type is submit. And I just want to click that button. So let's see how that goes. A lot of these frameworks have different APIs, so I'm still trying to figure them out myself, so that's why I keep jumping back and forth between the docs, but it's more consideration to make sure that your API does have a lot of documentation, so that's one more thing to consider when you're looking at these frameworks, which one to choose. I think I found that most of them have like really good documentation as it is, so I haven't really had that as an issue to pick on. Basically, it's created the contact, and I can go back down and like find foo. So the next step would be basically just find and assert that element. So in terms of the time, I think I'll just move on to the next framework and we can do it in that one instead. So that was basically WebDriver as the quick sort of dirty hack of writing a spec. So to conclude, it seems like they have a lot of options. Whatever you expect in Selenium WebDriver is available to you. So if you're used to working in that environment, then you'll be right at home. It's got the ability to sort of, I guess, choose from many different frameworks, which is a big plus if you want to play around with like Gherkin syntax and like write sort of BDD style specs as opposed to regular TDD style scripts. And debugging is supported, but you need to sort of configure it. So you basically launch Node with a breakpoint, and then that way you can go into the dev tools in Chrome and then hit the breakpoint and then step through. It's not as nice as other frameworks we're going to see in a moment, but like it's still an option and it's available. So if your test is not working and your spec is just failing for very strange errors you can't quite diagnose, that's when you need to sort of jump into the debugger and then figure out what's actually happening on the page. So those cons I mentioned earlier. Moving on to the next one, Cypress, which is kind of an interesting framework that I heard about at another talk in JSConf in San Diego, and they were playing around with that, and it looked really cool, and I saw maybe I should just try that out myself and just see how easy and accessible it is. So their motto is like the web has changed, and they want to focus on efficiency and sort of determinism and parallelism and all the benefits I mentioned earlier, so that kind of excited me. It meant like maybe they're going in the right direction, they're kind of aligning the goals of the web and testing together. And it's meant to be sort of fun and joyous to write and easy to interpret and use. It's sort of an application that you run and it's built on Electron, and then you just launch that application and it does the rest for you. So it's kind of like an integrated sort of development environment for testing alongside your regular coding environment. And it uses Chromium. It's basically steadfast in its Chrome sort of dedication. So you don't have the option of running it in different browsers, but you do have a very sort of cohesive set of tools that are very strongly built around DevTools. So you'll notice that it works out of the box very well, but it may not be as configurable as, say, WebDriver. You can also run it in like headless mode if you want to run it in CI or if you just want to run it more performantly. And the great thing about this is there was no configuration out of the box. I just needed to just point it to my test files essentially, and it would just work. So let's see how it works. Clear that away. If we look at the package.json file again, just as a quick index on like what else is out there, Cypress essentially just runs an open command, and the headless one runs a run command. So it's fairly easy to figure out. Oh, sorry about that. It works on my machine. Okay, sorry about that. So I was just pointing out Cypress and Cypress headless. The open and run commands are pretty easy and straightforward. So if I just run Cypress by itself, it goes away from like a scary terminal into like a nice UI. And that UI lets you sort of configure and customize your test framework, run your tests. It's basically like a one-stop sort of dashboard for everything. So I have a test written called contacts.spec. And if I look what that does, I just have like another directory in Cypress and then integration. It has a whole bunch of plugins and actually like a lot of examples where they even test their own sort of web page just to showcase like what it can do. And that's pretty cool, like dog fooding. So if we go into the spec, you'll find that it's, again, very simple. It just visits the same page before every test runs. And then the first one, all it does is just make sure that the item exists on the page, the very first item. So if we run that, what does that look like for someone running on these? You just need to click on the test, and then it'll launch Chromium. The cool thing about this is that it has all the steps that it executed on the left, and you can actually verify what elements they hit, along with the assertions that they were made. So, can everyone see that? Let's make it bigger for a sec. You know what endpoints it hit based on like the visited URL. You can see which elements it visited and also the assertions it made. So it's very clear about what's happening, which is great. And then you can also target the elements on the page, and you can actually use your application after the tests have run. So it's a great sort of end screen to have, essentially. So you can like verify what was the last stage your testing framework hit before it broke. And that's really important to have, and you don't have to like sort of put in like pauses and like waits and stuff as you're writing the spec. So it's great for like the workflow, I think. So having that sort of 3-stage TDD workflow is pretty awesome in this tool at least. So if we go ahead and go back to the code, I'm going to try writing the same spec as I did earlier, but in Cypress. So what I'll want to do is probably click on the same button as I did earlier. So you have this cypress.get, and that'll essentially target the elements with a selector. I believe it was this selector. And so then we can also click on that element. You'll notice that I believe this is also running synchronously, so every single line will basically wait until it's done and then move on to the next one. So that's very easy and accessible for someone who doesn't need to worry about like sort of parallelism and events flying everywhere. So we just want to click on that button, and then we want to find, again, the element, the H1 element. So again, I'll go see what I get the H1 element, and then I want to run like a query. It has its own built-in sort of should. And that function lets you sort of ask whether it contains certain text, for instance. And we want to make sure it says create contact, as before. And then we want to make sure that we can type something into the fields. So I'm pretty sure it has a .type, I believe. Let's go check out the docs. It'll be under like the API. Yes. So you have basically a type function you can use, and then it'll just type text into an element. So what we'll do is target the same selectors as we did earlier. Oops. It's a bit hard to type on an angle. And then we'll just do the same thing for all the different fields we had. You also want to test, I guess, the error if you were making this a comprehensive suite, but okay. And then at the end, we just click on the button to submit. And so that'll basically just be another click method. So the API, I found it was very simple to use. The get is like a very simple catch-all for everything you could possibly put into a selector, and it's great to have like sort of the, I guess the should API that alongside the elements you get back, the wrapped elements. So everything's kind of built in. You don't really need to include any extra libraries. You just write your spec. Oops. Okay, so assuming the API is what I say it is. Oh, sorry, you don't actually rerun anything. When you save, it'll adaptively reload your code. So that was a not unnecessary step, but let's just try running it. I'll also try maybe just to focus that test as well so that I don't have to look at the previous one. So if I go back into Cypress and then just hit that test again, it'll launch the browser. Hopefully it won't break. Cool. So then if I scroll all the way down, I can find the element, but it has mechanisms for finding text in the entire page and then verifying that that element exists and so on. So I'll leave that up to the user. So in terms of pros, it's super simple to get started. I didn't really need to configure anything apart from which URL to open. It captured everything for me as well, and I guess in a video folder, which is really cool. So if I go and explore that, it'll basically just show whatever was playing back, and having that automatic is really cool and kind of excites me into like the way of like bringing about like that kind of functionality in CI in the past has been sort of making sure that we can play around with different libraries and like setups, and it's a lot more customized and takes much harder effort to sort of set up. This is all like built in and ready to go, and you can basically see like the videos loading up in this videos directory. So it's pretty cool. It's all happening for you out of the box. It's super debuggable. So you notice that on the right side it was viewing my actual page. What you can actually do is like open up the debugger tool within that right side of the pane and not even play around with the elements, but also set breakpoints. So I can set debugger breakpoints in my code and then also rerun them just to showcase what that means. If you ever have a test suite break on you, usually it's something to do with like the element or the page or some attribute. So I was just curious, like, can I actually do this? And it turns out, yes, you can. So if I go into sources and then I find like contact list, for instance. This is not very readable from back there, sorry, but I'll make it a bit bigger. If I say I wanted to maybe hit the render method or something and just make sure that the inputs are correct and all that stuff, I can just fire away and it'll stop there and like let me interrogate the inputs and make sure everything's correct, and then I can go, okay, fine, great. Carry on, and then it'll run the rest of the test and come back to it when it needs to refresh itself when it comes back to the page the next time. So it's really cool for a developer to have this functionality. And I think as an engineer running on like sort of a spec framework, it's super useful. And if you're writing the tests as well, having that easy sort of, I guess, debuggability is super powerful. It has great documentation, as you saw, so I couldn't remember the method, so I went in and typed something up, and I was able to find everything great. The thing is, it is Chrome-based so far only, so if you have any other requirements for different browsers, you might find yourself at a stopgap solution where you need to sort of work with Chrome for a while. And it also is heavily sort of dependent on like Mocha and Chai, so it's made a lot of opinionated choices for you, but they're very good choices, and I think there were no surprises for me at least. So the next one I tried was Jest and Puppeteer. I think we have about 7 minutes left, I think. So just to like go through this quickly without any code, Jest is basically a sort of a unit testing framework built by Facebook, and the fact that it was also working in tandem with React and Jest, it means that the community is quite strong there. So if you chose it as a unit testing framework, it's an obvious choice for a React app, and like you'll get a lot of benefits from having that ecosystem. And then alongside that, Puppeteer, which we saw an awesome talk by from the previous people, I think it just showcases that you can combine two different frameworks together that have different strengths, and then sort of build a holistic model that is not monolithic. It's just a combination of different libraries that work well together. And I think that's kind of like the the takeaway message from like using something like React versus Angular is that rather than having a monolithic sort of developing experience, you kind of cherry pick the components and libraries that like work best for you, and then build your own ecosystem out of that. So I'll just like show you how it runs, I guess. One thing I found was that Jest was very quick for unit testing, and likewise Puppeteer and like Jest as a combination was very performant. So if I look into, oh, sorry about that. I'll just open my IDE again. If I go into Jest, you'll just see I have like a complete, so I'll probably run that instead. I think this test is fine too. So I actually like went ahead and wrote like the edit step as well, and I just tried to play around with the API. You'll notice that it has like a lot of async and await from the Puppeteer stuff. So that basically means that you can run these in isolation, or you can run them in parallel, and then it basically just waits for that step to finish before it moves on to the next one. So I just wrote the edit step, and I wrote a bunch of utility functions. I went really hard on this particular framework because I was kind of curious how it worked. So if I ran that, it would basically just run from the command line. The good thing about Jest is it watches for all changes in all files, so often you only want to look at one particular file, and so it avoids having to detract you from like running the entire spec. It only runs the files that have changed. So that's a huge like benefit, and the reporting is really clean and simple and easy to read, and like it points out like where in the particular component things are failing. So those are all the pros and cons I mentioned. I think as it depends on whether or not you want a framework that's very customizable and easy to use, you'd go with something like this. If you want something that works very easily out of the box, then I would use the previous option. So like I think there's a bunch of different ways to configure this, but if you want something that's easy to use, Cypress is like a really cool framework that I found really accessible. And if you want something more customizable, then Jest and Puppeteer I think are worth looking at. And there's also like a, I guess, exploration around whether we want Gherkin style syntax and scenarios. The previous speaker showed like that really cool sort of text file approach, and having that accessible to all stakeholders is really cool. If you prefer having scripts, the benefits of that is that you can essentially pull in any libraries you want, run any code you want within the means of the framework, and it's very customizable and easy to execute. So as long as you don't have users that need to read this from the business, and you just have developers or like automation engineers, that's a really cool option to have, and like you're able to mix and match whatever frameworks you want. Whatever libraries you want. Those are all the resources, and I've got about 5 minutes left, so any questions? Yes?
I have two questions, and I feel you being in both development and testing would help answer this.
Cool.
We all know when we do manual testing, the speed with which we do it is good enough to make sure that the element is interactable, but we will encounter while automation that hey, we clicked on this, but it was a premature interaction.
Yeah.
So the way we work around it is waiting for load or not present, ideally, just to ensure that we can do that. But otherwise, the elements usually, in some cases, it's present, it's visible, but it's not interactable in terms of like the split second where automation just finds and then interacts with it. So is it good practice to recommend adding loaders in especially places that we're testing around in terms of interacting when we encounter this, or do we just recommend adding loaders wherever until the element is ready for interaction?
I think I've had that experience in the past that when we're running them in parallel and the framework is initially built as just to run in series, we run into a lot of those event issues, and just I think to get around that, at least I haven't had those issues with like testing these frameworks. It could be that it's a combination of, I guess, the frameworks being more resilient, or React being better tuned for just mounting when it's completed in the rendering phase. So I haven't had the issue of like using an input that isn't ready to accept any input yet. I think there are various functions you can use. Like if you checked out the Jest option, there was a function I could call in Puppeteer to wait till the element was visible. But again, because it's browser technology, you might have the case where for certain tests, you might hit the element before it's actually completed rendering. I think the rendering loop in React would mean that it would mount after. So I think it might prevent from that happening, I guess. But you can also have cases where you have like asynchronous code running to set something up in the constructor, for instance, and then you might need to like have that sort of baked into the test suite to know, this will take a while, or there's like maybe a progress bar to look at, that kind of thing. So that's a good point. I think it's a challenge you need to face. I'm not really sure which of these frameworks works best.
Cypress. I've encountered this while using Cypress.
Oh, right. Okay. Yeah, it's surprising because like it's the spec was asynchronous. Sorry, it was synchronous, so it should be blocking on every line. But I guess there's cases where you can hit that. Yeah, I think there's a lot. Like I've only hit the tip of the iceberg, and like there's so much more to explore. And like I'm sure like as you guys go through and like try these out, or you've already had experiences with them, you probably have a lot more to say for each individual framework. So probably use like the lunchtime that's coming up now just to talk about like your experiences and contrast. So let's see, I'm gonna ask a question. I'll make it easy. I think that worked well last time. We got a lot of people responding. So how about what was the assertion framework library? Sorry, that I used for assertions. I think that guy was first. Yes, he put his hand up first. Actually. Maybe just repeat what I said.